Hi, my name is Synthmore Exemplum. I am the right-hand man of Open Hexagon, as you could call me. But here I am. I'm going to quickly explain how this entire Bad Apple video was created in Open Hexagon, because it uses the entire Open Hexagon engine to render every single pixel that you just saw. So let's start off with the basics. The level that the Bad Apple movie is contained in is actually another level called TI-84, and TI-84 is just your basic calculator level and all that sort of stuff. This movie was meant to be sort of like an Easter egg. It's hidden in the pack, and you just only manage to find it if you randomly stumble across it, but I'm guessing by uploading this video, it won't really be that much of an Easter egg anymore. But these are just normal patterns. This has nothing to do with the actual movie itself. This is just setting a bunch of things. Here is where we actually start to initialize the movie itself. So we check to make sure that the difficulty multiplier is 0, because we only want the movie to play if the difficulty multiplier is 0. Because in Open Hexagon, a difficulty multiplier of 0 is completely impractical. It's actually not possible to play a level in Open Hexagon difficulty 0, because in difficulty 0, the walls will stop moving completely, so you won't have a level to work with in the first place. So that's why he decided to choose difficulty multiplier 0, because you actually cannot even play a level at all if the difficulty multiplier is 0. But when the difficulty multiplier is 0, it triggers a Boolean, movie equals true. It tells the level that we're going to be playing the Bad Apple movie. So let's talk about the data real quick. So usually you're going to find it in your workshop content, the ID for Open Hexagon, and here's the ID for this pack. You go into the data folder, and you're going to be able to find Bad Apple data right here. It's about 11 megs in size, and the only reason why the file size is this big is because this is a text file. It's not a binary file, because Open Hexagon's engine is very restrictive on input-output libraries, because we had to restrict it previously because there were security vulnerabilities that people could do. By using the IO library, people could use Open Hexagon to create malware, and that's not something that we want. But we will try to expand the capabilities of the IO library, reintroduce some of those features back, as long as we don't find critical security vulnerabilities with the engine. But that's the reason why the file size is so big. If it were to be a binary file, I imagine the file size would be much smaller than this. I imagine it'd be probably like 1 meg. 1 to 2 megs instead of 11. But here's the file open up here. Give it a second, because there's like millions of characters in here. So it's taking Notepad++ a second for it to get all of those characters. Okay, so as you can see, this is a bunch of gibberish right here, so you're probably not going to find anything useful out here. But this is all like data for like every pixel in every position that the pixel is supposed to be in, whether it has to be turned on or turned off. Because how the pixels are drawn is that it draws an entire square of pixels, and they are in an on and off state. If they are on the on state, then the pixel is white. If they are in the off state, then the pixel is black. But back to the TI-84. So that's the Bad Apple data. It's essentially responsible for the entire film, and so it looks through 3 different directories to ensure that it can find it, because we want to make sure it's a fail-safe method and we are able to get that data. So it first looks in your default installation path, your external Steam library path, or it tries to do a local path. And if it doesn't find any of these, then of course it will warn you saying that the data is not found. You just need to get that resolved. But for the most part, you should be able to load this file unless you have some weird file configuration on where your data is stored. So of course, we alter a lot of the attributes for the level to make sure that the movie is in perfect view. which involves setting the pulse and okay, so not the radius, but we do set the pulse, so that way we could see more of the screen, so that way we could see the movie. So we set the style, movie, which is just a simple black and white style. And we have the music, which is Bad Apple, but for this video, I had to edit it in because for some reason the engine is currently not playing the music. I think this is a bug, but that's because I'm running it on a beta build. So it should be fixed sometime soon, but this is what's going to play the music. And of course, what this is doing right here is it's creating all the custom walls. It's initializing all of those pixels. So we get a 160 by 120 video. We have 160 pixels for our width and 120 for our height. And this is the code creating all those pixels. When we go to on step, this is where we're actually going to be updating the video and updating those frames to make sure that we are updating each frame. And these are different flags and all that sort of stuff, and they are useful different indicators as to what to do to the file data. I'm assuming with $S, it is a way for the program to say, hey, this is the end of the file, stop everything, and game over real soon. So when we update the video, we are actually reading in a buffer, which is reading in a cluster of the text information that is being used to get the video information. And this is a binary operation being performed, shifting the buffer over by a specific amount of pixels. Hi, VoiceOver More Exemplum here. I just want to make a simple correction because apparently I do not know my binary operators. That is a binary and operator, not a shift operator. So it is actually not shifting the frames over with that binary operation. It is actually a simple mask to simply determine which pixels to change and which ones to not change. Because if we were to just simply reapply the colors every frame, then we would get a much laggier video. It's completely fine if you aren't understanding what a whole lot of the deep down operations are doing. You do kind of need a little bit of background in computer science in order to be able to understand all of this. So if you are not somebody who is familiar with binary operators and how all of this works, then no worries, just smile and nod and just assume that it all works, okay? And of course, the more colors that have to be set, then the more computing power that it takes, which is why in certain moments of the video, you'll probably see when there's a lot of pixels that had to be changed, there's some lag that occurs within the video. That's because a lot of pixels have to change color, and of course that takes a lot more computing power to do. I want to give a shout out to the man who actually made this possible. His name is Sirion. He's an absolute mad lad for actually managing to pull off actual video playback in Open Hexagon. I imagined this is something that was possible, but I didn't think this is something that people would actually manage to pull off. And the fact that somebody actually managed to pull all of this off with just a simple custom wall system is beyond me. Like, I don't think I could do this myself. That's how impressive this is to me. If you actually want to see the Bad Apple movie for yourself, you can actually purchase Open Hexagon on Steam. The link is in the description, and you just download the pack that is on the workshop, which you can also find a link to in the description as well. Go ahead and check it out for yourself. I think it's really cool of what Sirion is doing with custom walls and pushing a lot of limitations with the Open Hexagon engine. I'm pretty sure Sirion will probably answer any further questions that you guys may have in the comment section down below. But yeah, that's pretty much it. That's how Bad Apple works in Open Hexagon. check out Open Hexagon. The workshop pack and the game itself are in the description. You could also join our Discord server. We would like to see some new faces in the Discord server. It would be really appreciated. And yeah, that's pretty much all I have to say. If you enjoyed this video, please leave a like, subscribe, and hit the bell icon to be notified for any future uploads. This is my second channel, by the way. If you want to see what's on my main channel, you can go ahead and subscribe there as well. But I obviously don't make a whole lot of Open Hexagon content. This is just an exception because I want to show off the technical prowess that people have been pulling off with Open Hexagon, and it just blows my mind seeing how far Open Hexagon has come. Alright, that's it. Take care.